This is the extra practice worksheet for Unit 12 to prepare for the test. Number 1, what is the value of x? Well, we know x is right here, which is a central angle because the vertex of the angle is on the center. Central angles are going to be equal to their intercepted arc. So the measures of those two values are the same. So that means in this case x is equal, or x degrees equals 103 degrees.
Luke Haynes, please report to the attendance office at this time. Luke Haynes, please report to the attendance office.
Number 2, what is the measure? Oh, so that was our answer. For number 2, what is the measure of angle D? Well, angle D is right here. The vertex is not on the center, it is on the circle, and the endpoints are also on the circle, which means this is called an inscribed angle. The measure of an inscribed angle is equal to half of its intercepted arc. So it's going to be half of that arc BE, which would be 64 divided by 2, which is 32 degrees. So that is the measure of angle D. Number 3, what is the measure of the intercepted arc for angle B? So angle B is here, which means its endpoints are D and C. The intercepted arc for angle DBC is arc DC. So we want to know the measure of arc DC. This is an inscribed angle because the vertex is on the circle, so we have to multiply by 2 to get the arc. So our answer is 184 degrees for the measure of arc DC. The difference between number 2 and 3 is I'm going from the arc to the angle in number 2, and I'm going from the angle to the arc in number 3. They're both inscribed angles, but we have to remember that the arc is twice as much of the angle, and the angle is half as much as the arc. So your arc is always the bigger measure. That's just because it's further away from this opening. So, going to number 4, these are all central angles, which means their arcs are equal to their angle measurements. What is the measure of arc DCB? DCB is all the way around. And what is the measure of arc BD? So I want 2 separate answers here. First of all, the measure of arc DCB is this entire arc where this part, each angle is the same because these are central angles as their arc. So I add up 150 plus 97. Which is 247. And that gives me the measure of arc DCB, 247 degrees. And then the other arc is the rest of the circle. So I would have to take the entire amount of a circle, which is 360 degrees, subtract the pink part to get the blue part. So subtract the measure of arc DCB from 360, which is 113 degrees, and that is equal to the measure of the minor arc BD. Minor arcs are less than 180, and you want to go the shortest path from B to D. Number 5, what is the degree measure of arc CB? Arc CB is right here. So I need to be very careful of what I'm looking at. CBD is an inscribed angle, so I can double it to get this arc out here, which will give me 104 degrees. And then you can also see that BD is a diameter, which makes this entire side a semicircle. So if I do 180 minus 104, I can find the leftover of the arc, which would be 76 degrees. So the measure of arc CB
Luke Haynes, please report to attendance. Luke Haynes, please
76
report
degrees.
to attendance. And all staff members, please post your attendance. Thank you.
Number 6. Are arcs BE and CD congruent? If they're congruent, they would have the same angle measure. So let's check. We're looking at BE and CD. Well, CB is a diameter, which because it cuts through the center, which means this is a semicircle, so it has to add up to 180. If those were congruent, then I could add all three of these angles together, and they would all equate 180, and then all of these arcs would also add to 180. Well, I know 50 plus 50 is 100, and 100 plus 80 is 180, so yes. And that's because you could add up 80 plus 50, which is 130, and subtract that from 180 to get 50 degrees of your leftover angle. Number 7. What is the measure of arc RCB? So that means we have to start at R, go around to C, and end at B. Well, I don't have the measure of any of these arcs, but I do know a term for each of them, and that they all add up to 360. So I can add every single one of these up. So 7x plus 4x plus 4x plus 3x, and set them equal to 360, because one full circle around is 360 degrees. So when I add all these together, 7 plus 4 plus 4 plus 3 gives me 18, so 18x equals 360. So then you're going to do 360 divided by 18, and you get x is equal to 20. But it says what is the measure of arc RCB. So I want to know this entire part. If x is 20, I do 20 times 7 to get this first arc, and 20 times 7 is 140. This arc over here would be 4 times 20. 4 times 20 is 80. And then that entire arc would be those two added together. So 140 plus 80, which would give me 220 degrees, which is equal to the measure of arc RCB. Number 8, what is the measure of arc DB, which is here? Well, I don't have a diameter on this one, but I do know arc DY, and I can find arc BY by doubling my inscribed angle. So this arc would be 150 degrees, because 75 times 2 is 150. And then I could add those together and subtract from 360, or do 360 minus 150 minus 80 to get my leftover angle. 360 minus 150 minus 80 equals 130 degrees, which is equal to the measure of arc BD, or DB. Either way is fine. Number 9. What is the measure of angle A? Well, in order to find angle A, I need to know arc A, because I only know arcs here. So I can add up 165 and 95, which is 260, and then subtract from 360. 360 minus 260 is 100, which means this leftover angle is 100 degrees. If I add all three of these together, all the way around the circle should equal 360 degrees. This is an inscribed angle. An inscribed angle is half of the arc, so angle A is 50 degrees. Flipping to the back side. Number 10, what is the value of x? Well, x is an inscribed angle. The endpoints are not labeled, but we know that these 2 points are where the endpoints are. So if I draw in the arc for that angle, it goes there. Well, 67 is also an angle that's inscribed. So that means this 67 is half of this inscribed arc. I can double it to get the arc, which is 134 degrees. 67 times 2 is 134. Well, this angle is an intercepted arc of 134, so I divide by 2 to get x, which means x is equal to 67 degrees, which also makes those two angles congruent. Number 11, are the dotted arcs congruent? Why or why not? Well, if I start with this angle here, I know that this angle is vertical to the angle on the other side because these diameters are straight lines. So those two angles are congruent. If this angle is angle x, or x degrees, this arc would also be x degrees because it's a central angle, which means the angle is equal to its intercepted arc. That means the vertical angle is also x degrees, and this angle is also x degrees, or this arc is also x degrees because it's a central angle over here as well. So yes, by central angles and vertical angles, they are congruent. Number 12, BC is a diameter. What is the measure of arc DC? You want to find arc DC. If BC is a diameter, that means that these two angles add up to 180. So if I add them together, 9x plus 6x is 15x. Negative 35 and negative 10 is negative 45. If you want to show that separately, you would do 9x minus 35 and combine it with 6x and negative 10. And you would get this. Those two are along a diameter, which is a straight line, which has to equal 180 degrees. Solving that equation, I add 45 to each side. And I get 15x equals 225. 225 divided by 15 would solve for x. Which will give you 15. But it says, what is the measure of arc DC? So in order to find the measure of arc DC, I need to plug x in for 9x minus 35. So 9 times 15 minus 35. 9 times 15 is 135. minus 35 gives me 100. So the measure of arc DC is equal to 100 degrees. Number 13. Angle C is 40 degrees. What is the measure of arc CB? So I want to find this measure here. Well, it's shown that these two sides are congruent to each other that make this triangle, which means it's an isosceles triangle. We also know those two sides are congruent because they're each a radius of a circle, and the radius is the same all the way around the circle. Other properties of isosceles triangles we know is that the two base angles are congruent to each other, and that all angles in a triangle add up to 180. So 180 minus 40 would give me angle A, which gives me 100 degrees for angle A. If CB is an intercepted arc of a central angle, it should be the same as a central angle. So the measure of arc CB is also 100 degrees. Number 14. This is an inscribed angle, so I need to take half of the intercepted arc to get the angle. That angle would equal 70 degrees, but I also know that that angle equals 2x plus 10. If 2x plus 10 and 70 are the same angle, then you can set them equal to each other to solve. Subtracting 10 to the other side, I get 2x equals 60, so x is equal to 30, because I divide 60 by 2. This is what is the value of x, so you can stop at that point. Number 15. If an inscribed angle in a circle intercepts a semicircle, what is true about the measure of the angle? If an inscribed angle in a circle intercepts a semicircle, here is a semicircle, the right-hand side. The inscribed angle would be a point on the center, and its endpoints intercept the semicircle. So you could draw it like that. You can put the part on the circle very close to one of the other points, but no matter how you draw it, it intercepts a semicircle, so it's intercepting an angle of 180 degrees because it's half a way around the circle. An inscribed angle is half of the arc, the intercepted arc. So half of 180 is 90. So what is true about the measure of the angle? You can say the measure of the angle would equal 90 degrees, or you can tell me it is a right angle. Number 16. Refer to circle O where ABCD is inscribed in circle O. AC is the diameter. AC, the diameter. And the measure of angle DAB is 122 degrees. Oh, I'm sorry. That's the measure of the angle, not the measure of the arc. So the measure of this angle DAB is 122 degrees. Calculate the measure of angle BCD. So we want to find BCD, whatever this measure is here. So there's a couple ways we can do that. First of all, we know that if an inscribed angle intercepts a diameter, then that angle is half of the semicircle, which makes B and D each right angles. This inside is a kite, so I can use my properties of quadrilaterals. All my angles in a quadrilateral add up to 360. So I can do 90 plus 90 plus 122 and subtract it from 360. So 360 minus 90 minus 90 minus 122 should give me my last angle. Which is 58 degrees. And the measure of angle BCD. What are the measures of ADC and ABC? Well, we already solved those. They're each 90 degrees because they are inscribed angles. That intercept a semicircle. Or semicircles. And that's the end of Unit 12 Extra Practice.